Okay, 7.11. Number one, the absolute value of y minus 7 is less than or equal to 4. So one thing I want to mention at the start is that anytime we have an absolute value, well, let me go back a little bit. First, isolate the absolute value. In this case, that means we don't have anything to do, but if we had, say, on the left side of the inequality symbol, if we had something besides the absolute value here, the absolute value, maybe a -2, we'd get rid of the -2. We'll look at an example like that here in a minute. But first, isolate the absolute value, and next you want to notice that it is the absolute value is less. Hopefully everybody's familiar with the inequality symbols. If that sort of mouth looking part of it, if it's open away from the absolute value, that means the absolute value is less. And once you've got the absolute value by itself, you can take what's inside it, the y minus 7, and we'll continue to have it less than or equal to 4. And then on the left side, it's going to be greater than or equal to -4. So we're just tacking this bit onto the left side. And then I won't do this for every single one, but let me go back. We've got a left side, a middle, and a right side. On this one, typically you just have a left side and a right side with an equation. But with a compound inequality, you've got 3 different parts. And we're going to try to get the y by itself in the middle. So to get the y by itself, we're going to add 7. And make sure you add 7 in all 3 sections. So we're going to bring down the inequality symbol. Here, -7 and +7 cancel, and we're left with y in the middle. 4 plus 7 on the right, -4 plus 7 on the left, and we've got 3 is less than or equal to y, which is less than or equal to 11. So if you're taking notes, you do want to make note of the fact that this is what we call algebraic notation. And it has a letter. We've got that y in the middle. So that tells us that we've got algebraic notation. 2 other things that you'll be asked to do besides algebraic notation is graph. And a graph just looks like a number line. Significant numbers on there are 3 and 11, and something you might put at the top of your notes, I'll write it on the side here. Anytime you have the inequality symbols with the line on the bottom, we're going to use a bracket on the graph. And anytime you have less than or greater than without the line underneath, without the or equal to part, or you have negative infinity or positive infinity, on all of these, we're just going to use a parentheses. Okay, so bracket if it's got a line underneath. And in this case, at 3, if we look at here, y is greater than or equal to 3. So greater than means y could be 4, it could be 5, it could be 6, or it could also be 3. So I'm going to put a bracket at 3. Bracket looks like sort of a rigid parentheses. And then at 11, we're going to use a bracket also. Y is less than or equal to 11. So things less than 11, 10, 9, 8. So that's what your graph should look like. And when you go to do the last thing that we're asked for, which is interval notation. Interval notation. And by the way, make sure you pay attention to which one of these it's asking for. Because you may have 5 problems in a row where they ask for interval notation, and then the 6th one they ask for algebraic notation. So pay attention to the instructions in this section. And your interval notation looks just like your graph. So it's going to start with a bracket at 3, and then you've got a comma that goes up to 11, and then close bracket. So the interval notation matches the graph. And I would recommend that every time you work one of these out, you do the algebraic notation, and then next you do the graph, and then next you do the interval notation, and then go and enter your answer into the computer. Because they may ask these out of order. Okay, so hopefully that one makes sense. We got our algebraic notation, our graph, and our interval notation. Okay, number 2. 3 times the absolute value of x plus 3 plus 7 is less than or equal to 13. So any of these ones with the absolute value symbols, we're going to get the absolute value by itself. So that means that we need to get rid of this 3. We need to get rid of the 7. The 3 is butted up against the absolute value, so we'll get rid of that last. Going to start out by getting rid of the 7. Subtract both sides by 7. Bring down our inequality. 13 minus 7 is 6. And now on the left, we've got the 3 and the absolute value. At this point, got to get rid of the 3 because we're still trying to get the absolute value by itself. So we're going to divide 3. And we end up with the absolute value all by itself now. Less than or equal to 2. 6 divided by 3 is 2. Okay, and then just like the last one, we're going to take what's inside. Less than or equal to 2. And then on the left side of this, same symbol and the number -2. So we go from the absolute value all by itself, and since it's less than, we solve it this way. Absolute value is less than. Then we just go through our steps to get x by itself. Subtract 3. Make sure you do that on the left, center, and right. Bring down our inequality symbol. Got 2 minus 3 is -1. -2 minus 3 is -5. And hopefully everyone remembers that this is algebraic notation. And in case it asks for that, and you'll do the graph next. Significant numbers are -5 and -1. And we've got a line underneath, so that means we're using a bracket on both of these. By the way, just as a side note, in your keypad, when you're in the software, you've got a little button that says keypad. You'll press on that, and it'll give you some options, some of which would be a pair of parentheses, maybe a parenthesis bracket, maybe a bracket parenthesis, and then maybe a bracket bracket. And in this case, since you've got a bracket on the left and a bracket on the right, we would press keypad and then select this last option, bracket bracket. It'll show up on the graph, and you'll just move the left bracket to -5, you move the right bracket to -1, and then you're done with your graph. Okay, and then lastly, our interval notation matches the graph, -5, comma, -1, and we've got a bracket. Okay, number 3, the absolute value of x minus 3 is greater than 9. So first thing we want to do is isolate the absolute value. And in this case, and in some other cases, there's really nothing to do for that first step. The absolute value is already by itself on the left side of the inequality symbol. So we can check that off. And one thing I want to note about this one is that the absolute value is greater. So in this case, that mouth is open up towards the absolute value, so the absolute value is greater. And that means on most problems we'll do the x minus 3 like this, but in this case you're not going to do that because it's greater. So for the greater, we're going to do x minus 3 is greater than 9, and then or, so we're going to have two separate inequalities. X minus 3 is greater than 9, or x minus 3 is less than negative 9. So the inequality symbol is changed. It's not open to the x minus 3 anymore. On the first one it is, on the other one it switches, and we've got a different sign. So that's how you set it up, and then we'll just solve those two inequalities. Okay, so we end up with x is greater than 12, or x is less than negative 6. These solutions both have a letter, so that's algebraic notation. Our graph, and again, I want to emphasize, make sure when you're working these problems out on paper, it's probably a good idea to do all three at the same time. Algebraic notation, then graph, then interval notation, then go enter your answer in the computer. So our significant numbers here are 12 and negative 6. And on these greater ones, you'll want to notice how it reads. So this says x is greater than 12. That mouth is open towards x. X is greater than 12. So that could be 13, 14, 15, all the things to the right of 12. And since it doesn't have the line underneath, we're going to go ahead and use a parentheses facing all those things, the 13, the 14, all the things greater than 12. And that goes up to 100, 100,000, a million, on and on up to infinity. And you might remember that for infinity, we use another parentheses. Going over to the x is less than negative 6. So less than negative 6 would be negative 7, negative 10, negative 100. Everything to the left of negative 6 on down to what we call negative infinity. Really, really, really small numbers. So negative infinity, we use a parentheses also. So that would be our graph. And our interval notation looks just like that. You start from the left at negative infinity, where we've got a parentheses, up to negative 6. We've got 12 up to infinity, with another parentheses at the end of infinity. And what you'll want to do is put a U in the middle. And this is a U, not the letter U necessarily, but this is a U that you'll find in the keypad. And that would be our interval notation. So again, interval notation matches the graph. The leftmost thing first, the negative infinity in the parentheses. Interval notation. So again, just to recap, we started by getting the absolute value by itself, nothing to do there. We noticed that the absolute value is greater, so we set up two separate, with the or in the middle, two separate inequalities. Number 4, 11 is less than or equal to the absolute value of 6 minus 3x minus 1. Isolate the absolute value, and just to hammer that point, what I mean is we've got a right side of the inequality symbol and we've got a left side of the inequality symbol. On the right side, the absolute value has a -1 with it. So we'll get rid of the -1 by adding it. So now we've got 12 less than or equal to the absolute value, which is now all by itself. And here, notice, since that mouth is open toward the absolute value is greater. So this is that one where we do the or. We separate them. So we've got 12 less than or equal to 6 minus 3x. And then or -12 is greater or equal to 6 minus 3x. So we're using a different sign on the number, and then the inequality, that mouth is now open the other direction. So those are the two inequalities that you want to come up with. And really nothing that different here. I just wanted to show an example of, when the absolute value is on the right side of the inequality as opposed to the left. So trying to get x by itself, we're going to get rid of the 6. So that leaves us with -3x. Going to divide by -3 to get that x by itself. And then one thing that's important here to note, if we divide by a negative, reverse the symbol. So that mouth, that inequality symbol in the middle, is going to switch, and it's now going to be open towards the opposite side. So this symbol is now going to be open towards the left. So 6 divided by -3 is -2, and then on the right we just have x. So working on this one now, we want to get the x by itself. We're going to subtract 6. -12 minus 6 is -18. -3x on the right. Want to get that x by itself, so divide -3. And again, this is one of those instances where we're dividing by a negative, so that mouth in the middle should reverse. We got x on the right and then +6 on the left. So both of these, this is our algebraic notation. Algebraic notation. Got our graph. Significant numbers are 6 and -2. -2 over here, 6 over here. And going to use a bracket. X is less than -2. All the way down to, this is -infinity down here. On the right, using a bracket again, x is greater than 6. So that goes all the way up to infinity. And then our interval notation looks just like the graph. So this is the graph. And then our interval notation starts at -infinity with the parentheses, goes all the way up to -2. We've got a graph. And then at the 6, we've got a bracket going all the way up to infinity, where we've got a parentheses, and we put that u in the middle. So while you're doing the homework, again, keep paying attention to whether or not it's asking you for algebraic or interval. You could do everything correctly, but if you enter in interval notation where it should be algebraic, it's going to count it wrong. So make sure you pay attention to the directions on that. Most of the time you can ignore the instructions, but on 7-Eleven you'll want to pay attention to the fine print. Number 5, 3 times the absolute value of y minus 2 plus 12 is less than 7. So we're going to go through most of the same steps that we've done. Isolate the absolute value. So we're going to subtract 12. Seven minus 12 is negative 5. And we want to continue to work to get the absolute value by itself. So this 3 out front, we're going to divide. And now we've got the absolute value all by itself. Okay, and I want to make a really big point here. This will come up rarely, but occasionally. If you've got an absolute value means distance from 0. So the distance that 5 is from 0 would be 5. The distance that negative 5 is from 0 is also 5. Distance is always positive. So make sure you notice this. An absolute value cannot be less than a negative. I could say it can't be less than 0. That would also be true. It can't be less than anything negative. And in this case, we've got an absolute value that is less than negative 5/3. If you end up with your absolute value all by itself and it is less than a negative, there is no solution. So you really don't even need to work any further with that one. So hopefully you remember that, and it'll be a nice surprise when it happens because it means you don't have to work any further with that inequality. All right. Good luck.